Okay, hello everybody. This is your first classwork of the day. We're just briefly going to talk about computer output, what that looks like, and then we're going to talk about regression to the mean. So to start with computer output, a lot of times when you're looking at statistical information, they will give you the data summarized in a computer output of some sorts. There's lots of different softwares that you can use, and so the outputs might vary slightly, but in general, this is what they're going to look like, and this is something that you could see on the AP. So I want to go over and make sure that it makes sense to you. So first of all, on here, as you can see, this one is from Minitab. And you want to be able to make sure you can identify the different features specifically of the least squared regression line and some other helpful things like S and R squared. So when you're looking at something like this, we want to pay attention to the coefficients. Okay, that's what we're really looking at. And so down here, your constant, right? That's always going to be a constant, right? Is not attached to any variable. So that's your y-intercept. That's your a value. Okay. And then your slope is always attached to whatever explanatory variable that you have, right? So this is b. So that's kind of how I remember which is which when I'm looking at this. And so if you wanted to, you could write the equation of the LSRL, right? So we would have y hat equals 3.8257 plus 0.16292x. So now you have a different way of getting your equation as well from this computer output. Other important things to note here are the other two things that are highlighted, and that is r squared and s. So they also give you those values as well. If you needed to get r, you can simply square root, and then you can figure out if it should be positive or negative. So if you are given something like this is how you read it. We're going to be practicing with this. You'll kind of see those throughout the year. So I just wanted to kind of go over that with you. Next, just a few little things on regression. The distinction between explanatory and response variables is important. If you switch them, the correlation is not affected, but definitely your least squared regression line is, right? If you flip them, you may have something that's more positive, more, steeper slope, things like that. Different y-intercept, those types of things. So definitely think about that in terms of how that's affecting correlation and the line as well. Remember that correlation and regression only describe linear relationships. If you see here below, they give you 4 examples. Some statisticians figure this out. These all actually have the same exact correlation and the same exact least squared regression line. But however, we only want to really use that if we have a linear relationship, like B, definitely not. A, you could tell there's somewhat of a linear relationship, right? And so when we're looking at things like that, that's what we want to be careful of. And the last thing on here, correlation and the least squared regression line are not resistant. So what that means is that any data point that you have in your set of data is going to affect those things, okay? Then go ahead and flip to the back. And we're going to talk about something called regression to the mean. In your last video, they briefly talked about this, how the point X bar, Y bar will always be on the least squared regression line. And so remember that the symbol for the bar just means mean. So what they do is they take the mean of all those X's, mean of all those Y's. That's actually directly in the middle of your line, and it's always going to be on your line, okay? The whole thing is created with regression in relation to those values as they are collected, right? Everything is going to be either closer to that or further away from that. So that is an important thing to note. And we can actually calculate the equation of the regression line using our means of our X and our Y and our correlation coefficient R. So that's what we're going to do today. Now it says how to calculate the least squared regression. So from the data, you could calculate means and standard deviations of the variables, right? You can put it into your one-bar stats and whatnot, but more than likely they're going to be giving you those things instead of the data and still ask you for the equation of the least squared regression line. So these formulas are on your formula sheet. And so I want to make sure that we point them out. So these are your 2 formulas. And again, you do not need to memorize them. They are on your formula sheet. The second one is written a little bit differently. On your formula sheet, it looks like this: Y bar equals A plus B X bar. So it says the same exact thing. It's just formatted differently, just adding BX to both sides. So those are given to you on your formula sheet. And so when might we use these? So if we look here, here's an example. It says 15 high school students investigate the relationship between foot length and height. The mean and standard deviation for foot length are given, and the mean and standard deviation for height are given as well. The correlation is 0.697. So if we have to find the equation. Now, one thing to note is that when you're looking at these equations, you can see that in the second one, you have to use B in that second one, which means I have to do the equation with B first. So I'm going to go ahead and do that first. So they already gave us all the important info. Always love to make sure that we're highlighting that. And they may not always tell you what's X and Y. So you have to make sure you're paying attention to what's your explanatory and what's your response. So here, I'm going to go ahead and solve for B. And so I will plug in my R value, 0.697 times the standard deviation of Y, which is 10.69 divided by the standard deviation of X, which is 2.71. And then if we plug that into our calculators, we get a value of 2.75. So that's B. And then I'm going to go ahead and solve for A. So for A, I'm doing the mean of my Y, which is 171.43 minus the slope I just found, 2.75 times the mean of my X, so 24.76. And you can plug all of that in to get your value of A, which is 103.34. And then we can write off our final equation. So the final equation looks like this, 103.34 plus 2.75x. The other thing that you want to make sure that we always do, we've stressed this already in class, is to make sure that you define your variables. So Y hat is predicted height, and that's in centimeters. And then our X value is representing the foot length in centimeters. And so that is a full example on how, if you're given that information, you're still able to come up with the equation of the least squared regression line. Let me know if you have any questions.